Hello, from Portugal. My name is Ana. I'm the clinical practice specialist at Sensing Future Technologies, and I would like to start by thanking you for being here and for taking interest in this topic, and most of all, for helping us fulfill our mission of thinking about everyone in the world who suffers from balance disorders, and also for contributing for increasing the quality of care of these patients. Um, Moreover, I hope you're having fun with the World Cup. Portugal is playing in a few hours, so our team is ready for to watch the match in a few hours. But we have this first, so let's go to work. In today's webinar, we are going to explore a simple framework for an instrumented balance assessment. So we can get started. So once again, thank you for supporting us and for keeping with us during these events and showing your interest. So before we move into the assessment framework itself, we need to talk a little bit about balance and we need to understand how balance works and what are the main mechanisms behind a good balance response and how they interact with each other. So then we can build an assessment protocol with confidence. So we say and we know that balance control serves two purposes, or you can say that we have to achieve two goals. The first one is postural orientation. So we need to achieve postural orientation. We need to know where we are in space in relationship to our environment, to our surroundings. And to do this, we need to collect information from the outside and also from inside so we can build our own avatar in space. After we reach this stage, after we understand where we are ready to achieve postural stability. So we can activate the correct motor output to control our center of mass within the base of support. Okay, so as all other mechanisms that are related to motor control, postural control or the balance response also emerges from the interaction between the individual and the sensory motor systems of the individual, the environment, and the task. So we know that different environments and different types of tasks signify a different balance response. And so the individual and the sensory motor systems need to be adapted and flexible enough to respond to differences in the environment and differences in terms of goals of tasks that we want to do. So we are starting with the first goal, I would say postural orientation. And we already see a part of an infographic that represents the balance control system and introduces the assessment component. So let's focus first on the first and the second step. So first of all, we need to collect sensory information from outside and from inside through our main sensory systems. So we have the visual system that gives us visual cues of our surroundings, of the characteristics of the environment, if there's movement, if there's what is the where is the vertical when we look into upright objects. So we are talking about external cues these cues come from outside of the body. Then we have the vestibular system that, in the other hand, uses internal information to understand linear and angular acceleration of the head, and to also gives us this notion of verticality. So we can, with eyes closed, still understand where the gravitational vertical is. And then we have the somatosensory system that allows us to have proprioceptive input, which allows us to perceive joint position and movement, the relationship between the different body segments, and the characteristics of the base of support itself. So this information needs to get to the central nervous system and is integrated and organized centrally. So as Professor Brunstein states in his work about multisensory integration, so the information coming from these systems is most of the times, not most of the times, but frequently can be overlapping. So there's a significant degree of redundancy in the information, because we can get the same message from the three different systems, but sometimes in different environments this does not happen. So the message that comes from each one of the sensory systems is not in accordance to the others. So what happens when the message is incongruent, when they are not talking the same language? So sensory integration works in a hierarchical system according to the context and the challenge. This means that the weight from each sensory information varies according to the environment. So this process is named sensory reawakening, and it's a fundamental step for postural orientation. This is what ensures us that we can navigate different environments with different qualities and availability of sensory information. So I have a few examples here that really demonstrate the need of having this flexibility. So the first example, we see people in a roller coaster. So in this situation, the vestibular system is going to need to compensate for the lack of visual information. So visual information here is not going to give us much. Most people will have their eyes closed. And so we need to compensate, and the vestibular system, that is the one that gives us information regarding acceleration of the head, linear and angular acceleration of the air, is going to at least let us still have some postural orientation when we are in such a challenging situation. But a more relatable scenario would be the one that we see a man walking at night. So here we have decrease in the quantity of the visual information. So what needs to happen is that centrally there's a need of calibrating process that will increase the weight of the information coming from the somatosensory system and from the vestibular, but especially from the somatosensory system. So the person will feel the floor, the characteristics, will focus more on the feelings coming from the base of support to compensate for the lack of visual input. On the bottom left, we have a situation where it's not about the amount of visual information, is the quality of this information, because it is not making sense. So this is a cobblestone walk in Lisbon. We have this a lot in Portugal, where this image tricks us to think that the floor might be moving, there might be ups and downs, and we know that it's not what is happening. But this means that for us to be able to safely go through this through this path, we need to again increase the weight on the information coming from the somatosensory system and from the vestibular system. And the last one, we have a picture of a boot that is buried in mud. So here, the quality of the somatosensory information is compromised. And so here we need to have an increase of the weight of the information coming from the visual and the vestibular. But the visual, we are going to be looking, and this is inconscient, but we are going to be looking more into what our feet and our paws. So these are just some examples that explain why we need this, and why this is very important is because daily life requires us to accurately organize this information so we can move on and walk and do our daily life activities in the different environments, because walking inside is different from walking outside. A busy road is different from a less busy road. Walking at night is different than walking during the day. So we need to ask, when we have a patient that comes with any balance problems, not only if the information is coming, so if the sensory systems are collecting the information, but if this process is also happening in an efficient way. So we need to ask this question. So can the visual and the somatosensory system maintain a functional level of balance? How does the subject react in darkness or with a lack of visual depth, or when large objects are moving nearby? Or what is the impact in balance when the somatosensory system becomes unreliable on uneven surfaces like stones, sand, and grass? Okay. So this is where the modified clinical test of sensory integration in balance can be a helpful tool. It's a simplified tool to test the integration of the information coming from the sensory systems in only 4 test conditions. So it is not a diagnostic test. We are not assessing if there's problems in the vestibular or in the somatosensory system. We are trying to understand how the patient uses the information and how well the patient can adapt when we change and manipulate the environment in terms of availability and quality of the sensory information that the patient has available. So we have 4 test conditions for this test. We have the first condition where we have the patient, and this is the control condition, where we have a patient standing on a firm surface with eyes open. So here we do not have any compromises or changes in the quality and quantity of the sensory input. On the second condition, we maintain the surface, the stable surface, but we ask the patient to close the eyes. So here we are removing the visual information from the equation, and we are left with the proprioceptive and the vestibular information to work with. On the third condition, we are going to add a foam pad, and the foam pad is going to decrease the quality of the proprioceptive information. And so, as a compensation, the vestibular and the visual system would need to be able to respond to this test condition. And on the fourth and the last condition, we maintain the foam pad, but we ask the patient to close the eyes. And here, the only system that is not changed, that's not altered, is the vestibular system. Okay, so this is how the test goes. How do we measure balance? How can we say that the patient is more stable, is less stable, so how can we do this? We do this by using balance platforms, and this type of platforms, they measure the center of pressure location, which we can think about it as being the projection of the center of mass within the base of support during a quiet stance. And we do the tracking of this point. And so at the end, what we see is the displacement of this point that represents the body sway. So we can see by the displacement area if the patient has swayed a lot or no. So we can compare the different test conditions and see how the patient adapts when we move from condition to condition. So this example that I have here is from a patient that was taking vestibular suppressors. So we have from the test, the first condition, a good balance response. On the second condition, where we remove the visual information and the proprioceptive information should be the one that weights more, the patient could still maintain a good level of balance. But when we had a foam path, things change, and we see by the area of displacement that the patient has swayed significantly more compared with the first and the second condition. So on the fourth condition, as expected, this even got worsened. So what we see here is that this patient might be more reliant on the quality of the information coming from the base of support to compensate for the decrease of the vestibular input. So it's not as much as the visual information that makes a difference for this patient, it's more the quality of the support surface that can make things worse. And so also as an educational strategy, we can let this patient know that it seems like when the patient is in unstable surfaces, it might face a situation where the risk of fall is higher. So we can let the patient know this, and we can use this information to also program our intervention. Okay, and that's the goal. So we have used the test for assessing the postural orientation part of the balance response, but now we need a test that can measure and assess the stability, the postural stability, the motor output. And this is where the limits of stability can also be a great tool. So assessing the limits of stability allows us to evaluate postural stability under involuntary motor control. So this is especially relevant because most daily life activities require us to push our limits of stability. And so this test, the goal of this test is to assess how much the patient can displace his center of pressure or center of mass towards the limits of the base of support, and how well and how safe can the patient produce this movement. So both aspects are very important, and they also are considered in the literature to be sensible to assess fall risk or to detect patients with a higher fall risk. So if we think about having a small area of stability, you can think about it as having a low margin of error to sway before we need to build a new base of support or we lose balance. And the quality of the movement itself is, we can think about as a safety that the patient has on controlling their center of mass and doing these center of mass corrections within the base of support. So I also want to show you some real examples of limits of stability tests. So the first one that we see is from a 76-year-old man, that we see that the area of stability is reduced, but the most important thing or the most relevant thing here is the asymmetry between the left and right quadrants. So we see there's a poor directional control and poor movement excursion towards the left targets, towards the left side. So this will help us to again to plan the intervention process for this patient. Just next to this example, we have an 82 years old with a very good area of stability and very good directional control. So there's a very good symmetry between left and right quadrants. Of course, there's always a difference because of our dominant side, but this is a very good test for an elderly patient. And below, we have a different scenario where we have a 66 years old patient with a good area of stability, but with very, very poor directional control. So let us see what we could do. So for the first patient, the 76 years old, that we saw that there was difficulties on performing weight transfers toward the left and lack of directional control, we can use exercises to target the left quadrants and start with simple exercises, moving from dots to dots, and then moving into a more difficult exercise where the patient needs to maintain a center of pressure towards within the pass, so it requires more precision of movement. Or we can also use games to stimulate in a fun way the patient to transfer the weight and keep the weight on the side that is struggling more, so the left side. So just a few simple examples. And so for the other patient, the 66-year-old patient with a very poor directional control, we would focus more in using small scale weight shifts movements, but focusing more on movement precision. So we could use this type of exercises where the patient needs to keep his center of pressure on top of a pot, performing small scale movements but with precision. And on the right, we have an exercise where the patient needs to react to the movement of the target itself. So he needs to do small adjustments to keep his center of pressure on top of the target. Or a game that also uses control movements to lead the glowing triangle towards the target in all planes of movement, because here we see that there's is not a symmetry problem, is a poor directional control, and it's general to every direction, so we need to work in every direction. So the good news is that this framework is available as an infographic on physiosensing.net for free download, with additional material like ebooks and past webinars. We have our social media pages on the bottom, so we can keep up to date. We also released and organized a library of content. So there are blog articles, but this library is organized into categories, so you can better go and search for what you want to study with more details. So we have a category for balance physiology, balance dysfunction, assessment, and rehabilitation, and then a different category for technology, so the use of different technologies for both balance assessment and rehabilitation, with posturography and baropodometry. So I think it's a good source of theoretical content that might be helpful. And also on the website, you can explore our complete range of solutions for balance assessment and rehabilitation. So you'll find systems that are designed more for vestibular rehabilitation, others that are more for physical rehabilitation, and also entry-level technology. So if you'd like to learn more, feel free to get in touch at any time. You can also follow us on social media to stay updated on our latest development, events, and educational content that we try to share and upload it frequently. And most of all, thank you again for being today here with us. And I hope I see you on our next webinar. Bye.